All right. So I need to look at the original because those numbers are going to modify the original. So let's get our original picture up here. And see what changes we're going to make with, this is the last quiz question. So here's our original. Okay, so now we've got 2f of 2x. Now we remember that when we add or subtract, we pick it up and put it down somewhere else. When we multiply, we do what? What changes happen when you multiply? Size. So all we got to do is remember the rules. What does this guy do? He's going to be twice as tall. Whatever this number is, that multiplies the height. So if that were a 1/5, it would be 1/5 as tall. Now what does this number do? Half as wide. This number essentially divides. Instead of multiplying, it divides. So if it were a 1/3, we would divide by 1/3, which is timesing by 3. This number does the opposite. It looks like multiplication, it's actually a division. So now I'm going to draw that picture, but it's going to be twice as tall and half as wide. So it's going to look like this. That little v, Evan, is going down to, but all in the space of 1 unit. Instead of 2, it's been squished into 1. This is going all the way up to 6 and coming down at 3 halves, at 1 1/2. Because it was 3 wide before, now it's only 1 1/2 wide. Okay? Now, kids, those are the rules. We got to memorize and practice the rules. Right? There's no negotiation there. You have to just know it. Anything else on your quiz? All right?
Yes, yeah.
Huh?
I have a question.
What?
Number 2.
What's your question about number 2? We get t by itself. You did not do that, JR. So we have to get t by itself. So t would equal x minus 3 over 2. And why did we get t by itself? So we can plug it in right here. So y equals x minus 3 over 2 squared. And I think I have given you partial credit for the last time for making this mistake. That is not right. What is it supposed to be? Evan?
X minus 3 times x minus 3.
Exactly. It's a FOIL. It's a FOIL. No, it's supposed to be multiplied out. I didn't mark it wrong this time, but I will. It's supposed to be multiplied out. Anything else from the quiz? All right, let's get our homework out then. Those of you that did it. What issues did you have? Jake.
I just have a general question, like quiz and everything. I know you said we we have to like know formulas about like area of cylinder and like spheres.
Yes.
All seven?
She said that. And I was checking, making
But I
sure.
mean, when you say all seven, that sounds like a lot, but it's 1/2 base times height is one of them. I mean, some of them are incredibly
Yeah.
simple. So you're probably only gonna need to review a couple of them.
Okay.
Raise your hand up. Oh, no.
Did I do 9D?
9, number 4.
9D. Sure, I guess it's.
Yeah, okay. All right, let's do part 4 of letter D. I think we need to do the other parts though, before we do it, at least part of the other parts. So let's look at number 9. This is the one I told you all along is going to be on the test. You got a piece of paper. Actually, those of you that pay attention to such things, probably if it's on the review sheet, it's on the test, right? That's how it's kind of gone so far. So we need to know not just the box problem, we need to know everything. Okay, so here's our piece of paper. We're taking out the corners. What's the formula or the equation for my volume? 12 minus 2x, 18 minus 2x, and that's the equation for the volume. What's the domain of this equation? In other words, what are you going to put in for x min and x max when you go to graph this? 0 to 6. Perfect. Everybody good? So you're going to draw that picture on your calculator. It isn't going to be a perfect parabola, but it's going to be a hill, right? You're going to see a hill, and you're going to find the maximum using the second calc max option. And did anybody do that?
Yes.
2.35, 228.16. Okay. Now, when the question was, what is the maximum volume? You answered 228.16 inches cubed, right? Cubic inches. Now, are there possible volumes? If I cut my paper different ways, are there possible volumes less than 228? Aren't there possible volumes less than 228? I think all of these are volumes less than 228, right?
Yes.
Are there volumes more than 228?
No.
No, that's the maximum. But there are lower ones. So if this is 228, somewhere in here there's a volume, actually 2 places, there's a volume that's 150. Right? Just think about it when you all made your boxes. Somebody made a box whose volume was 150. So our job is to figure out, okay, that point is something, comma 150, and this point is something, comma 150, and we want to know the somethings. Because the somethings are the x's, and that will be the size of the cutouts that will produce 150. You can do this several different ways. I would suggest, since you already have this graphed on your calculator, just go back to y equals and add this equation. So leave that one there and just stick this one in. So then you have 2 equations. And when you hit graph, it should look just like this. You should see the parabola or the hill, and you should see the line coming across. In your second calc menu, not only is there 0 and max and min, but there's also intersect. So go to second calc, choose intersect. And if you go down there, hit intersect, it will say first curve, second curve, so that's like left bound, right bound, yes, and it will give you the coordinates of that point. That is not the only way to do the problem, but since you've already got that graphed, it's probably the fastest way to get that. And then you have to repeat the process for this one. Start over again, second calc. Okay, Jasmine, you all right?
I gotta practice it.
You'll have a chance when we're done here with questions. You can practice it. All right. Anybody else have a question about a review problem? Anything else on the sheet that you read it and said, I'm not sure what's going on? Alyssa?
Number 13, how?
So we are looking at two different curves. And by transformations, we mean anything that changes the curve. So we've talked about some already today. Adding and subtracting, how does that change the curve? Picks it up, down, left, and right, right? Multiplying, this one doesn't have any, but multipliers change the shape of the curve, the size of the curve. And what do negatives do? Flip you. Right? So back when you were in geometry, you talked about flips, turns, and slides. Now that you're big kids, we talk about them as reflections, rotations, and translations. So what has happened in this problem is you have exactly the same parabola. If you graphed this one and you graphed this one, they would be identical. The only thing that's different about them is where they are. Where's this one positioned? Left 2 and down 8. So this one's down here at -2, -8. Where's this one? I'll put on the same graph. Right 3 and down 4. So the question is simply, what would you have to do to this one to get it to be here? Well, you're going to have to move it 5 units to the right and 4 units up. Describe the transformations. Move it 5 units to the right, 4 units up. That's it. Well, you should be able to, in your mind, think about where this is. There's no way to do it without knowing where this is. So you got to somehow think -2, -8. Whether you draw that picture or not, it's up to you. But -2, -8 is where I'm starting. +3, -4 is where I'm ending. How do I get there? Anything else? Jasmine?
Could you do E for 4 and 5?
4E, find the inverse. I do want to talk about this for a second. Just stop for a second and look at the original. If I were talking about domain and range for the original, I really want you to be careful. This is my fault. I have programmed you that when you see a radical, what do you automatically think? I have programmed you to whatever's under the radical has to be positive. Kids, that's only for even roots. Because the reason I want to keep it positive is because I don't want to be imaginary. I don't want i's. And what's I? The definition of I. The square root of -1. You can take the cube root of negative numbers. If you type in cube root -8 on your calculator, it will give you an answer. What is the cube root of -8? -2. Negative times negative times negative would be a negative. So you can take the cube root, the 5th root, the 7th root of anything. So your domain is all real numbers. Okay? So again, I want you to be always vigilant about radical signs, but the ones that bother us are square root signs or 4th root signs. Okay, but I'm supposed to be doing the inverse here. So what are my steps to finding the inverse? This is the original problem. What are my steps to finding the inverse? Now, first I switch my variables. And now I need to solve for y. So how am I going to get that y out from under that radical? I'm going to cube both sides. Now, I want you to think about that for a second. If you were at all confused by that, I want you to remember inverses undo each other. If the original function cube roots, what will undo a cube root? A cubic root. They're kind of obviously inverses because they undo each other. The domain and range for both functions is all real numbers. You know what the cube looks like? The cube looks like this, domain and range, all real numbers. Its inverse looks like this. Domain and range, all real numbers. In other words, you can plug anything in and get anything out. The cubing function, by the way, is that 1-to-1? Yes, it is 1-to-1. 1-to-1 means you pass the vertical line test and the horizontal line test. It means you are a function and your inverse is a function. All right, tonight's homework, couple of comments. Your homework for tonight, that's just so there's no ambiguity, is the sheet that's called review number 2. It literally has a number 2 on it. Number 2. That's the one you're doing for homework.
I like the jumper.
Oh, it's my spirit number. Nope. Where,
Your St. Patrick's Day.
huh?
I said I could work for St. Patrick's Day.
Yeah.
Are you gonna
I'll
have
let you see my Valentine's jumper.
Are you gonna ever wear the tie-dye? Yeah.
Well, I have to wear that on special days. That was considered.
I saw you wearing
Read by the school administration, so
I saw you wearing the tie-dye dress during the summer when I was working the front desk.
You could be, for the seniors, our theme is 70s. Yeah. Yeah. So you can wear it
next week. I will.
Wait, isn't
What
it
day is
next
70s?
week? Well, it's like our theme day, so it'll be
The
Friday.
senior theme is 70 seniors, so the theme
Oh,
day.
that's a walkathon? I guess I could wear my jumper.
Yeah. Everyone can see you.
Okay, now that we're done discussing my wardrobe, your homework is the sheet that's called number 2. Now, you have a weekend. Monday's homework, tonight's homework, due Monday. When I check homework on Monday, you're going to have review 2 done. If you have extra time, Monday night's homework is going to be something in the packet called practice test. There's a practice test in there. But on Monday's assignment, practice test is assigned. But additional to that, I have put some optional book problems on Schoology. So if you feel like you need extra practice or want extra practice, they're optional. But on Monday's day, I have listed some review problems from the book that maybe if you have time this weekend, you might want to do. Not checking them, not going over, I'll answer questions about them, but they're not required. I just wanted you to know they're there in case you are so inclined to do extra work. Yes, Jake?
Where's the practice quiz?
The practice test